Hi, my name's Jay McGavran, and together with Logan Barnett, we maintain Gemini, which is a Ruby library for game development. Visit Gemini.org to learn how to download and install the library. In this screencast, we'll be creating a simple shooter called Gauntica. It's a cross between Galaga and Gauntlet. So let's get started. Similar to Rails, Gemini will make a basic project directory structure for you. We do that by typing Gemini at a prompt, followed by the name of the project we want to create, Gauntica in this case. Let's change into the directory and take a quick look at its structure. You can see all the jar libraries installed for you, and there's the source directory at the bottom. That's where we'll be spending most of our time. So let's edit the project. And you'll notice to start with, we get hello world.state. That's a basic state that is intended for you to replace with your own code. So that's going to become the basis for our game's menu. Let's rename it to menu state. We do that by renaming the file and the class within it. And Gemini will know when we go to load the menu state later that menu state.rb is the file it needs to access. The load method is responsible for setting up the state when it's first created. We call the create method with the symbols background and Gauntica, which tells it Gemini to create a new background object and to load gauntica.ping from the data directory. In a future version, you'll use Gemini run or a similar command to kick the game off, but for right now we've got a slightly lengthier command you'll need to type. Check the wiki for directions on how to run it. Whoops, we've hit our first bug. Looks like it's still attempting to load the hello world state. Your entire program is kicked off from main.rb, and that's what has the reference to the initial state to load. So we change it here from hello world state to menu state, and that should get it loading properly. And here's our menu state with the contents of gauntica.ping as the background. Let's add some music to our menus. To do that, we'll create a sound manager and then tell it what song we want it to loop through. So within our menu state's load manager, we'll set its sound manager to a new object of the sound manager class. We then tell that sound manager to loop a song from the data directory. And that'll load up menu.og. You can see it here if you go to the menu state directory within the data directory. And if we load it up, we'll see our menu state with looping music. Now let's introduce some game objects to our state. We're going to start by creating some text that prompts the player to press start. So we create text, which is a subclass of game object, specify what it should say, and then position it on the screen. And here you see our press space to start text at the center. We detect when the player has pressed start through events. We're going to create an event handler game object to detect that for us. So when we receive a start event, we're going to run a block, and within that block we're going to specify that we should switch to the play state so we can begin playing. What generates that start event? Well, we're going to take input from the keyboard, and we use an input mapping to map the spacebar to the start event. So let's create a new menu input file within the inputs directory. And within this file, we're going to use an input builder to specify which keys are mapped to which events. So we run it, press space, and the game promptly crashes. Why did it do that? Well, it tried to switch to the non-existent play state. So let's create that now and fix it. We create playstate.rb within the states directory. And create a new class that inherits from Gemini GameState. We need a load method similar to what you saw in the menu state, and then within that we're going to create a new sound manager in order to play some more music and do other sound effects. The song we're going to loop is called play.og. And it resides within the playstate subdirectory within the data directory. Our epic battle requires a battlefield, so let's create a pretty grass background. We create a background object and specify that it should load grassbackground.ping from the play data directory. Press space and it'll load our play state with grass background and pretty music. I can't imagine why anyone would ever want to quit our awesome game, but it's a feature users seem to demand, so we're going to create a quit option. We create an event handler object, and similar to the start event within the menu, we're going to handle the quit event here. When we receive it, we'll switch state back to the menu. The quit event is something we're going to need in both the play and menu states, so we're going to use our special global input.rb file in the inputs directory to handle it. It works the same as a specialized input mapping. We say in order to, the name of the event, and what keys we're going to press to generate it. So we press escape within our play state, and then again within our menu state, but that doesn't produce a reaction. So let's go back and fix that. We handle the quit event within the play state, but not the menu state. So let's go ahead and add an event handler for that here as well. and we're going to quit out of the entire game when we receive it at the menu. Escape now exits the play state and the menu state. Every game needs a hero to play as. We're going to have a little animated dwarf character. So we create dwarf.rb within the game objects directory. That's going to hold our dwarf class. Like most other things, he just inherits from Gemini game object. And to give him the ability to animate, we'll specify that he has the animated image behavior. We'll also give him the timeable behavior, which lets us set time-based events. To specify the animation files to use, we call the animateAs method and pass it the symbol dwarf, which will tell it to load all the dwarf underscore whatever .ping files from the play data directory. You can see them over there on the right. We tell an animated image how quickly to animate through its animation speed attribute. We'll just pick a value of 2 for now. And we'll give our dwarf the ability to move left and right by telling it to handle the move left and move right events. The move left event will be handled by the move left method, and the move right event by the move right method. The handler method will receive a message object, which among other things communicates how long it's been since the last update. We use that to ensure movement is smoother between slower and faster computers. So to move left, we subtract from the dwarf's current X position, and we take an amount times how long it's been since the last update. Let's go ahead and make that movement speed a constant so that we can easily change it later. And then we tell the object that when it moves left, it should use the walking animation. We do that via the animate pulse method. And again, we pass it the delta to keep the rate of animation smooth. The move right method is just the same, except we're going to add to the dwarf's X position instead of subtracting from it. We start the game back up, and look at our big empty field. We created a dwarf class, but we didn't create a dwarf object, so let's go back and fix that. We have a dwarf.rb within the game objects folder, and that means that anywhere we want to, we can call create and pass it the symbol dwarf and create a dwarf object. We do so within the load method for the play state, so that it's created at startup. We set its position to be midway across the screen. And 3/4 of the way down. Let's start the game back up. Enter the play state. And it bombs immediately. Why is that? Well, we told the dwarf to handle move left and move right events, but it looks like it doesn't know how. We need to give it the handles events behavior before we can use the handle event method. We start back up, and there's our dwarf in the center of the screen, but if you press left and right, there's no response. And that's because we created move left and move right methods without actually mapping keys to them. So let's create an input file for the play state. And specify that in order to generate the move left event, we hold the left key. Likewise, in order to move right, we hold the right key. Start the game back up, and voila, our dwarf can move left and right. He's barely animating at all, though. We can fix that by resetting his animation speed to something higher. And here's our animation. Our hero needs the ability to defend himself, so let's give that to him. We create a shoot event, and we'll have the shoot axe event handle it. That shoot axe method will receive an event object. And we're going to have it display the shoot animation. That, of course, loads ping files from the play data directory. And we're also going to play a sound, throw.wave. There's the ping file that'll be used when throwing. So when we shoot an axe, we're going to tell the sound manager to play throw.wave. Fire up the game to test it and press the spacebar, and of course nothing happens. We haven't mapped any keys to the shoot event, so let's do that now within the play input.rb. We'll say simply, in order to shoot, we press space. When we press space, we get our animation and sound, but no axes yet. Let's take care of that. In our shoot axe method, we're going to create an axe object. So we say game state create, which will add the object we create into this game state, and then pass it the symbol axe, which will load up axe.rb and create the object, an object from the class that's found inside. We go to the game objects directory and create axe.rb, and class X is going to inherit from Gemini game object. An axe only has one image file as opposed to multiple frames of an animation, so we're going to give it the drawable image behavior instead. We'll also give it the movable behavior so it can fly upwards. In its load method, we're going to assign it an image file. This will load up axe.ping from the play data directory. And just to make them look cool, let's make them spin as they fly. We're going to do that by altering its rotation a little bit every update. So we call the onUpdate method, and we're going to pass that a block. The block gets the delta, how long it's been since the last update, which decides how far the axe should spin. We add to its image rotation and multiply our default speed by the delta since the last update. Start the game and press space to throw an axe, and we see that indeed a spinning axe is created, just not in the right place. So when we create that axe, we're going to set its position equal to the dwarf's position. Last thing, the axes were stationary when we created them before, so we're going to tell them to move at an angle of 0, that's straight upwards, at a speed of 0.5. Now our hero looks a bit more menacing. Tune in next time and we'll create some enemies for our hero to fight. And meanwhile, be sure to visit the helpful documentation and forums on jemini.org to learn more. Thanks for watching.